In this video, we're going to talk about inverses of functions, and the whole concept of an inverse function is when we switch the x's and the y's. So all the inputs become the outputs, and all the outputs become the inputs. And because the domain is the set of all the x's and the range is the set of all the y's, the domain and range get swapped as well. So the official definition of an inverse is two functions, we'll call them f and g, are inverses if and only if. In mathematics, we write if and only if shorthand with two f's in the word if. So two functions f and g are inverses if and only if f of g of x is equal to x and g of f of x is equal to x as well. It's got to meet both of those conditions. You gotta be able to compose both of those functions in both directions and get out x. If one of those fails, then it's no longer, they're not a function. They're not inverses. So it's got to meet both of those conditions. Okay, so let's look at the first example. So we're going to check to see if these two functions, f and g, are inverses by composing them in both directions and seeing if we get out x both times. So first, let's check f of g of x. That means I'm going to take the entire function g of x and plug it into f. So that means I'm going to take x to the third minus 2 and plug it into the x in the cubed root function. Now, the minus 2 and the plus 2 disappear, and I'm left with the cubed root of x cubed, which is equal to x. So in this direction, it works. When I take f of g of x, I get x. Now let's check in the other direction, where I take g and plug in f of x into g. So that means I'm going to take the cubed root function and plug it into the x cubed minus 2 function. So I have the cubed root of x plus 2 all cubed, and then I subtract 2. Well, if I cubed a cubed root, then I'm going to be left with what's underneath the root, which is x plus 2. And then I subtract 2. The 2 and the minus 2 add to 0, and I'm left with just x. So when I compose g and f in this direction, I also get x. So this means, since it works in both directions, g and f are definitely inverses. Okay, now let's look at the next example. We're going to do the same thing. We have f and g, and we want to compose them in both directions to see if they're inverses. So let's do f of g first. I'm going to find f of g of x. That means I'm going to take the entire function g of x and plug it into f. So I'm going to take 2x plus 5 and plug it into 1/2 x minus 5. When I distribute the 1/2, that gives me x plus 5/2 minus 5. This does not give me just x when I simplify it. So I don't even need to do the other direction where we take g of f of x. I don't even need to do that. Because if it fails in one direction, then it fails the whole test. It only has to fail one of those conditions since it has to meet both of them. So, since it fails, then f and g in this example are not inverses.